Good afternoon, everyone. My name is Dave Anders. I'm with Intel and part of the Open Source Technology Center. Welcome everybody to the embedded track for SCaLE. This is the first year we've got the embedded track, and we'll be starting with the next presentation here in about 5 minutes. In the meantime, I just want to take a little quick survey, a show of hands. How many folks here are doing embedded work as part of their daily job? And let's show of hands, how many people have at least one embedded development board at home that they play with? And how many have two?
Who has one from Intel?
How many have 5 or more? And how many of you have so many boards that your spouse gives you so much trouble about where to place them? Our next presentation is by Ralf Quint. He's an independent developer. He's done quite a bit of different fields over the last 30 years. He's going to be doing a presentation about Internet of Things along with Intel products. And he's got, you have the Galileo or the?
Yeah, I just have an older Galileo. But things unfortunately didn't quite work out when I tried to this just before that. So demonstration part is unfortunately a little bit short here.
But a couple reminders again, make sure you fill out your speaker evaluations so that we know who to invite next year and make proposals. If you have suggestions, we'd love to hear from you on that. The lunch today is 1:15 to 2:45, I believe, and again, we also have a Yocto Developer Day that'd be the day after ELC, Embedded Linux Conference, on March 26th. So if you're interested in Yocto or an open embedded, it's a great opportunity to go and do a little bit of training. I'll turn it over to Ralf.
Yeah, hello. I want to talk today about Intel, which is supposedly the biggest chip manufacturer in the world, and what they are doing in terms of providing in terms of embedded boards for the Internet of Things. The Internet of Things is a little bit of a buzzword. Who does not know what exactly that means? Okay, you try to tease me here. So it's, as I said, it's a little bit of a buzzword that really came out in the last 2-3 years, basically, and it seems to be a kind of exploding market where everybody thinks everything nowadays has to be connected to the internet, and there need to be certain devices or computer device, embedded devices that actually provide this connectivity. So the talk today is basically what devices by default Intel provides that help you to connect things to the internet. Intel is actually in the embedded world for quite a while. In fact, they were one of the first ones who started back in the days. In the late 70s, 80s, they came out with some microcontrollers where the Intel 8051 is pretty much the most produced microcontroller ever. The most well-known one is probably one that is called the Intel 8048. That's actually the chip that provides actually the key presses in each keyboard, even nowadays, most of the time. That's pretty much a microcontroller where everything what is nowadays considered a microcontroller can trace back to that, together with some devices from Motorola. And back then there wasn't even the internet, so the connectivity that you had with these devices was absolutely minimal. This Intel 8051 had barely 4 I/O ports in the standard version. Intel themselves, basically, they stopped selling them in 2005, so pretty much 10 years ago. You still get them today, and they're still sold in large quantities because pretty much something like toasters or whatever needs any kind of adjustment control. There were about 40, 50 second source companies that still provide chips based on that very same design and the same programming tool that you used 20, 30 years ago, still work on that. But there's not much you can do on the internet these days. So a little bit fast forward, is that the Internet of Things basically is something around, or a term that is around for the last 2-3 years. And when I basically got into that on the business side in 2013, there are quite a few manufacturers for embedded chips around. As said here, they're in no particular order. Some of them might be known to people like ARM. Everybody who has a smartphone these days probably know what ARM is, or that they have an ARM chip. Some others like MIPS and STM might not be so well known. Atmel is the basic chip in most Arduino tool boards, which is pretty much the most well-known one, and even sometimes a little bit abused by the term for embedded development. But what I didn't find in 2013 was there was nothing from Intel. So the largest company in the world, chip manufacturer in the world, but they didn't have anything that would fit that need. On the other side, their revenues from PC manufacturing, their bread and butter business, is supposedly declining. So because everybody's going to even tablets and so forth, and ARM is taking them, for example, a big chunk out of their business. So they kind of looked into how to get back into this business. And then in October 2013, sorry, I didn't find a better graphic for it. Intel thought, okay, we have to get back into this market, and they introduced the Intel Galileo 1, which is basically the board that I have here, and try to do some demonstration, which is not quite working out. It's not quite as huge as it shows there on the picture, but it has quite a bit impressive array of features compared particular to the microcontroller of the 8051 that was around for 30 years. And among other things, basically it has Ethernet connectivity, not wireless, but built-in Ethernet port. It has a PCI Express connector at the bottom, which most commonly is actually used to provide wireless connectivity. You can pretty much take any micro PCI card that is in a laptop and connect it to in here to provide wireless connectivity. On the initial board, it was a problem that there were not drivers for a lot of those cards, just a very few select Intel boards. This has changed a little bit. There's quite a bit more available these days. Then also compared to other boards that are around, like Arduino, it has a vast amount of memory. And standard Arduino board, like an Arduino Uno, this is basically standard Arduino. This has a total of 32 kilobytes of flash ROM for program storage, and a whopping 2 kilobytes of RAM to work with for your variables. On the Intel Galileo, we have a total of 768 kilobytes at two different prices, 256 kilobytes of DRAM and 512K of SRAM, which is actually on the Quark chip itself. And it offers also by default a micro SD card, USB storage, but here's okay. So this is basically a diagram of how this is all connected. The core of this is basically a new chip where Intel tries to get more into the low power embedded market, which is called the Quark X1000. And the Quark X1000 is pretty much a 32-bit single thread, single core Pentium x86 compatible processor. So there's no multi-threading or anything that you have in the newer chips. It's pretty much going back to the days of an original Pentium, not even Pentium MMX. It does not have any of the MMX instructions. And then on top of the basic x86 core, they added basically what they call here the legacy block, some circuitry which basically provides like GPIO ports, real-time clock, or a serial port, or timer interrupt. In addition to that, then some stuff that is important for the internet connectivity, Ethernet, also USB controller is on the chip itself. So basically, it's this little chip here in the middle that provides most of the functionality, similar to what you have on the Arduino, which is basically here one DIL chip, which you even on the Arduino can take off and put it on a breadboard, and whatever is stored on here will still work on this one. It's unfortunately not that easy on the Intel Galileo. Unfortunately, with the first version of this board, they also had quite a few problems with, which probably was the reason why this at first wasn't, even so they made a big deal out of it. It wasn't very well received at first. It's, for one thing, where I personally think how a company like Intel, which should have quite a few electrical engineers, electronic engineers, how they brought out a board that is so finicky that even they warn everywhere you have to connect the 5-volt power first before you connect Ethernet or the USB port, or otherwise you might fry the board. So for anybody who, with most Arduino are targeted at, tries to use this with hobby embedded programming, this is already something that just kind of rules it out, because these things are not necessarily cheap. So, and if you just unintentionally basically plug in USB first and you fry the board, that they don't have any circuitry that will prevent that, that was kind of a little bit disappointing. The second thing was that the board was announced together with Arduino themselves. So Massimo Banzi and so forth, they made big presentation out of it at the Maker Faire in Rome in October 2013. On the other side, the problem is that the original version did all the Arduino compatible functionality that they promoted, all software emulated. So that made it excruciatingly slow. I have at the end of the presentation, there's a link to a Dr. Dobbs article where somebody actually was measuring why he had problems connecting an LCD display to it. It just wouldn't work. Even so, theoretically, all Arduino shields, so the shields is what the Arduino world calls the add-on boards, should work on it. All 5-volt boards should work. But he had a problem getting an LCD board to work. And he found out that this was because the I/O pins that were driving this LCD board were horribly slow. He'd measured something on an Arduino Leonardo. That was what he used as a comparison, a slightly newer version of the Arduino Uno that I have here. The Leonardo is able to pulse an I/O pin with a frequency of 100 kilohertz. So there's 100,000 times per second. When he measured this with an oscilloscope on the original Intel Galileo, he came to a whopping 223 hertz. So it's about 500 times slower. There are ways around that. Some people basically said, oh yeah, you can just write a new library which is called a fast I/O mode. The catch of that is, at that point, you are not compatible with any standard libraries for the Arduino, which was one of the selling points originally for the Intel Galileo 1. Because in the Arduino world, I talk a little bit about the Arduino IDE a little bit. All libraries, every code that you import or libraries you import are actually in source code, and they get compiled when you actually hit compile or upload the code to the board. So everything that is written there in C, C++ should run regardless of what the underlying processor is. But because of the software emulation of the I/O to the actual physical I/O on the Quark chip, it was so slow that you could use it only with separate independent libraries which were not compatible with the original Arduino libraries. And another little gimmick that they used for the serial port is a regular, so not USB, but RS-232 type serial port, which you sometimes need for certain type of sensors or certain relays or devices that you want to control, connect to the internet. They used a 3.5 millimeter barrel plug for the serial port. So if somebody found out there's actually a cable that the TiVo receiver use, and if you get a cable for that to program your TiVo, that would actually work on here as well. So there were quite a few things which didn't quite work out on the original Intel Galileo. So then less than a year ago, they came out with a board that is now called the Intel Galileo Generation 2. That's improved quite a bit on it. For one thing, they are not as finicky with the power anymore. You don't need the original Intel provided 5-volt power supply. It comes standard with a 12-volt and actually is able to use any power supply in a much wider range than the original 5-volt power supply that was used on the Intel Galileo 1. Also, the I/O stuff has improved quite a bit. They improved also the libraries for Arduino, so it is not as slow anymore than it used to be. So there has quite a bit been done. And also they changed the serial port. It's now actually on more accessible headers pins instead of this stupid barrel plug. Otherwise, it still has 10100 Ethernet, SD card, and there's still the same Arduino compatible headers for the add-on shields. So yeah, this is basically the serial port has been changed. One thing that was also a problem with the original Intel Galileo 1 was that the PWM, so pulse width modulation that you need to, for example, to control servos, had only a 10-bit resolution on the Intel Galileo 1. Now it has a 12-bit resolution, so you can much accurate, more fine-out, detailed adjustment of the power if you have any PWM controlled device. Mostly these are servos, but also can be LEDs if you want to basically increase the brightness of an LED. You can use PWM for that. On the serial port, they changed a few things internally, which basically makes you can use now a hard serial port, which directly connects the I/O port instead of what they call a soft serial. And it also has a PoE module, so that you can basically, if you power the are able to power the Galileo 2 through the Ethernet port, so that you don't need a separate power supply. So if you want to put something like I did, try to do some home automation stuff, you have this somewhere in the ceiling, you cannot always run power cable to. Besides that, the building inspector might not necessarily like that, but there you have the option to use this and power this board over the PoE. But it's an extra module that you have to add on. It comes not by default. And as I said, in general, for the power supply, there accept a wider range of power supplies. The default one is 12 volt that comes with it, but it accepts any power input on the barrel plugs between 7 and 15 volts. Then, before actually the Intel Galileo 2 came out, they announced something on the CES last year, which they called the Intel Edison. This thing is the size of an SD card. The problem was originally there was nothing given with or provided by Intel how to connect this to anything else. They had a demo where they showed some baby onesie where you could monitor your baby with, but otherwise there was not much that you could actually do with that one. It's this was based on the same Quark X100 chip that is on the Intel Galileo. It has a few internal features basically for I/O, but you have just only those few connectors basically, which are the same as on an SD card. So I think there are 7 or 8. So it was very hard to access them. Now the catch was when they actually did the presentation at the CES last year, and there was some guy from Intel showing this board. On the slide that they had there, they mentioned here a 22 millimeter dual core Intel Quark. The thing is, there is no such thing. The Quark X1000 is a 32 nanometer, single core CPU. Probably what they already had on the back burner or the slow burner was a complete new Intel Edison, and that came out actually in September. So they kind of tried to present something on the CES probably before they came out with the real thing half a year later. It's slightly bigger and it looked completely different, and its connect also completely different. Internally, we have a complete different CPU. That's why this 22 nanometer dual core in the original presentation comes for. They use a dual core Atom Silvermont CPU with 500 megahertz. That's basically the CPU that was referencing on the original slide. That is basically a Atom chip that is, or they're trying to sell it for smartphones to get basically in the business that they, or try to get some business away from ARM, which is the majority of CPUs in smartphones is simply ARM. And there are a few smartphones that actually have this particular Intel Atom processor in there. There's a link here, and you will see there's a total of 5 smartphones that run actually on this particular dual-core Atom. In addition to that, they have actually another X1000 processor on top of it. It's similar pretty much what they're doing to what is with the Arduino Yun, which is basically what I would call a hybrid processor, where you have a more high power from processing power chip that can run Linux on it as the operating system that you use to access it, connect to the internet. And the Quark processor is doing what the AVR part on a Arduino Yun is. That is the part that actually handles the I/O for all the I/O pins, GPIO pins. It comes with a gigabyte of RAM. It has built-in 2.4 and 5 gigahertz wireless, 4 gigabyte of flash ROM, which by default comes with a stripped-down version of the Yocto Linux that was mentioned here in the previous talk. And I think there's, right after me, after the lunch break, is a talk about specifically the Yocto Linux. So I/O basically has SD, I/O, serial port, SPI, GPO, and so forth, and USB 2.0 is built on the chip. But it comes on this flash ROM with the Yocto Linux version 1.6. I'm not sure if this is probably the same as on the Minnow board.
We don't ship with an OS.
No, I know it only by name. Sorry about that. And this is basically the size of it. Basically, it's 1.5 inches long, 1 inch wide. One problem with the Intel Edison is, however, because it is so tiny, it's hard to connect it to anything. The only way to connect it to the outside world, not talking about internet connection through the wireless right now, is they have a very small, this is less than an inch, this here ROSE connector, which is a 70 pin on less than an inch. So there's nothing like you can use on an Intel header, or sorry, Arduino header, where you can even use jumper cables to connect anything to a sensor or LEDs or a server or anything there. So in order to connect the Edison to anything that you want to control with it and connect to the internet, you have to get what's called some breakout boards. This is a default board that actually Intel recommends or provides, and that's an absolutely minimalistic breakout board, which is just slightly larger than the Edison itself. It has one USB port where you could connect basically either for the programming or to connect some USB-based device that you want to control. It has two serial ports, which are on headers, and also has an audio port. And there's another micro USB port, which is actually to provide power to this board. Otherwise, it's very limited what you can do with that breakout board yourself. But then Intel provides something that is quite a bit bigger. That's actually bigger than the Intel Galileo itself, which they call the Arduino kit, the Edison kit for Arduino, sorry. This basically, you plug the Edison on here, and it has an SD card connector, and the same Arduino version 1.0 standard headers. So all the Arduino shields should also work on this. And USB, standard size USB host port, and sorry, it's actually for power. And the two different, this here micro USB port. This is actually the switch, which switches between which USB port it should actually accept power from, or you can power it from a barrel plug. So yeah, there are a bunch of reset buttons which you didn't have on the mini breakout board at all. So if you need to reset parts of it, the shield, there's a separate reset for that. So you can basically just reset a shield if you basically have something like a center shield that need to be reactivated, reinitialized. You can reset that without resetting the chip itself or the running script for that. Then what I think is almost the most interesting part is that a company called SparkFun, they came up with their own whole set of breakout boards. They are slightly larger than the Intel Edison itself, and they use the system basically where you can stack different kind of boards on top of each other. So they have basically, this is what they call the base board, and this is here the provision for this high ROSE 70 pin connector, and then some USB port also to power and to program the Intel Edison, the chip itself, the software on it, and then things like a battery board, so you could even provide completely run this independent from an external power source if you basically would use something like a drone or anything else that does not have a available power source from the main lines. You can power this with battery, and on top of that they have some sensor and some I/O boards. So for example, here there's one board that just provides just an SD card. There's some touchscreen TFT display with buttons, or some I think this is a temperature sensor, and then you have the serial port, and this is basically a bunch of sensor ports or sensor boards, which they call blocks, and all these basically are supposed to then be stacked together just for whatever application you want to use it for. Now, the software, basically, there are several different options that you have there. There's actually something missing on this board. I actually got this from Intel's website. They, for one, mentioned the Arduino, what they call hosted software, which is pretty much the default Arduino IDE, just with a special compiler and, or let's say, special support for both the Intel Galileo and the Intel Edison. So it's just one software version that you need that supports both of the boards. And the other option basically is to boot the Yocto Linux off the SD card. And that's something I try to do and show a little bit. But unfortunately, it seems to boot, but I cannot connect to the Linux, neither through the USB port nor the Ethernet port. So maybe I had a problem here with a bad download or anything. I tried to fix that just before the presentation here. Unfortunately, that was negative. But if you're interested, basically, what you can do with the Yocto Linux, I think the talk that comes after me, they will go a little bit more into details on that. Besides that, as I said, both the Edison and the Galileo have a minimal Linux on board in the flash ROM. This is normally used as a bootloader, either to upload the sketch or receive the sketches from the Arduino IDE. And also, this is basically what initializes when you power the board on, and that will look, before it actually goes on further with itself, it will look if there's an SD card in there, will mount the file system, and then boot off that SD card whatever operating system you have on there. And there are so far two choices for that. So the default, what was originally also promoted when the Galileo 1 came out, is to use the same IDE that you use to program all the Arduino boards, just with special provisions for the Intel Galileo and the Edison board. And you would connect this through a USB port. Let me actually see if I can actually hook this up here right now. So the main difference from the programming point of view, if you want to program with the Arduino IDE for either the Galileo or Edison, is that you have much more RAM at your disposal as you have on any other Arduino board. Even the Arduino Due, which is basically the ARM-based Arduino board, you have a 96 kilobytes of RAM. On the Arduino Galileo, you have 768 kilobytes DRAM and SRAM, and it's 1 gigabyte on the Intel Edison. There's supposed to be a limitation of 256 kilobyte size for the sketch. That's what the program is called on an Arduino. The strange thing is when you actually compile, it will always tell you it uses so and so many bytes out of 10 megabytes. I don't know if this is just a bug or what it is, but I have, for all the things that I've tried with it, I didn't even get that far. An empty program on the Intel Galileo takes about 52 kilobytes. That is pretty much just the basic libraries that will be pulled in to provide basically also the software or connect to the software translation on the I/O ports. One thing where you need the Arduino IDE for is if you want to update the firmware, so the Linux on the flash RAM flash ROM in the both on the Galileo and Edison. For this, you need to upload this via the Arduino IDE. There's no separate program that Intel provides to update this Linux otherwise, and I've not found any instructions that would, by some third-party means, to provide for that. So that's basically, it's on a different link there. So for this, you would have to use the Arduino IDE, so that's kind of a must, even if you don't want to use it for your programming. Then, as I said, there's a basic minimalistic Linux on the board itself, but it's very limited what you can do. It has basically just a few things for basic communication. As I said, it has a bootloader for to load any image off the SD card, to receive the sketches, which are handled basically in a different memory layout than they are in Arduino. But otherwise, you cannot do anything much with it. There's no other programming language or anything, interpreter or so, on the embedded Linux. For that, you would have to boot Yocto Linux off the SD card. And this is pretty much the only Linux you can easily use on the Galileos or the Edison, because there's a bug, at least in the Galileo, on the Galileo, it's the only version that you have, because there's a bug in the lock code, which is used for usually on nowadays multi-threading CPUs, which every standard Linux distribution these days has somewhere in the startup code for the kernel, and they had to use special care to remove that lock code out of the kernel, that it would be able to start up the code. Otherwise, you kind of lock up the processor, which might remind me that might actually the reason why my Galileo he locked up. I might have accidentally gotten Edison code enabled. As I said, there is some talk after me. I wanted to show a little bit because this comes with Python by default. So anybody who is programming in Python, which is all the rage these days, you have full access to all the hardware and everything, and you could write your code on the Galileo, or the same goes for the Edison, in Python if you're so inclined. Another option, okay, here for example, this is basically a screenshot that I just put in here that I found on the web, where basically they do load start Python on a serial terminal and do a little bit stuff here on with some simple math and so forth on a couple lines of Python code, just to see what works with the built-in Python. In addition to the Python, which is there by default, it has become quite popular to use Java. There's some people that started very quickly to port Node.js onto the Galileo, and especially on the Edison. And one company that takes kind of advantage of this are the guys from Silent.js. I think they have a booth here, and I think they have a talk on Saturday, I think, or on Sunday, I'm not quite sure, where they're presenting pretty much what they're doing with Silent.js. They did this last year, I think, on an Arduino board, where they had the demonstration with a drone that they were flying around in a room here. So it's quite impressive what they can do with that, and this basically goes way beyond what you could do, for example, with an Arduino. Yeah, Intel themselves, they provide what they call a dev kit for it, which is pretty much an Eclipse-based C or C++ development environment, where you will actually cross-compile. You don't compile on the device itself, but on either the Linux, Mac, or Windows PC, and then transfer this onto the SD card image that you boot off the Galileo or the Edison, and that gives you pretty much, as far as programming goes, all the possibilities pretty much that you have or would need. And on top of that, there is, I know it's Linux Expo here, but also Microsoft tried to get back into the game here, and they provide for free an image for a core Windows on it that you can boot off an SD card. That would actually boot off this right now, but there is not much you can show. All that it comes with is basically a command line Windows. There's no graphical interface, because one thing that both the Galileo and the Edison are missing, there is no graphic I/O. I think you mentioned that the Minnow board has some graphics chips on there. So this is something that is completely missing on those. So this is only intended to be accessed from your application side via the internet, via a web browser. Windows comes with a minimal web browser. It's called WinMin, web server built in. While on the Linux version, you would have, I don't recall right now what is the server version, but this minimalistic web browser there, which provides access to things like JavaScript and so forth. And this is what you could use then on a web page through a web browser to access, either to control things, make changes to settings, or if you have sensors to get the response back, or even cameras have something streaming on it. So there is no graphic output. Using Windows on this one is also not very fast. It takes at least 2 minutes for Windows to come up. If you're used to programming using Arduino, this usually comes up in less than a second. I have even, as I said, when I did some home automation stuff where I was reading initial settings out of the EEPROM on an Arduino Mega, for example, I maybe get to 1.5 seconds, because reading the EEPROM is relatively slow on Arduino, but this is still light years faster until this is up and operational than before you have at least the Windows running. The Linux usually boots, I would say, in about 20 to 30 seconds until you're fully operational, that you can access it from the outside. So not necessarily within the same range that you have on an Arduino, but on the other side, you hope that you never have to reboot it that often, that you would have to start from scratch before you can access it. And just really when I started to set up my talk here, at the beginning of the month, some of the other guys came out with something completely new. And this is basically where I wonder how Intel is reacting on that. Raspberry Pi Foundation released the Raspberry Pi 2. And this is actually, I don't know, who is using Raspberry Pi here? Okay, quite a few. Who has a Raspberry Pi 2? A couple of them there. This is quite an amazing piece, which I think Intel has to react on that. The Edison, by the way, as you see, that I have some benchmarks that I found on the web, is pretty fast because it reuses a dual-core Atom processor, so the processing power there is significantly higher than it is on the just on the Quark chip. And the Raspberry Pi 2, basically, it is a 4-core ARM, 900 megahertz instead of the 700 megahertz single core, and it's an ARM A7, so it has full hardware floating point. That was a little bit of an issue with the original Raspberry Pi. It has 1 gigabyte of RAM, so twice as much as the original Raspberry Pi had, with all the I/O ports. So as it's Model B, so it has 40 I/O pins. That is more than is provided on either the Edison or the Intel Galileo. No wireless built in, but an Ethernet port. And it still sells for the same $35 that the original Raspberry Pi Model B sold for. And this morning I got an email from a Raspberry Pi blog where they mention on the Raspberry Pi.org site that within 2.5 weeks they sold 500,000 of those boards already. That is within 2.5 weeks, half of what they sold in their first year. So I think there is something where Intel has to come up with quite a bit of a response if they want to get any serious traction in the market there. Here's a comparison on the basic features that I took from this David Hunt website blog site, which really compares the Raspberry Pi, the original one, the two. There's a BeagleBone Black and the Edison. Now the Raspberry Pi and the BeagleBone have the advantage that they have a GPU on it, so they are similar like what you have on a Mino board, video on board, and it's actually pretty good. Even on the Raspberry Pi, the original one, for just being a 700 megahertz CPU, it's able to stream full HD video on it. That was the original Broadcom when they produced this ARM chip coming up with. And this guy David Hunt, he ran a benchmark on all these boards, and as you can see, the Raspberry Pi wasn't necessarily a high performant system. It was not designed for that. It was originally, the idea was to present a device to help kids, mainly kids, teach programming, which goes back to what was the BBC Micro in the UK. It's not very well known here in the US, but it's pretty much what the Apple II was in schools over here in the US. There was the BBC Micro over in England, where there was basically a government-sponsored computer IT education in basic schools in England that used basically the BBC Micro, and they tried to revive and that with the original Raspberry Pi. And as you can see, the Edison and the Raspberry Pi are from the basic processing speed almost identical. But the Raspberry Pi, even if you count in a power supply and an SD card, which is not in the $35 that is mentioned there, it comes about $50. To get an Intel Edison with a usable breakout board, you're spending at least $85 to $90. So that's definitely, let's say, the same processing power features that on some more features in terms of I/O that you have on a Raspberry Pi than you would have on the top of the line Intel Edison right now. So I'm kind of curious to see what the next move of Intel will be here to kind of counter that. So that's basically what we have to see on it.
If anyone has questions, I've got the microphone here. You can provide questions. Any questions?
Okay.
So if we're already in the Raspberry Pi camp, why would we look at this solution from Intel?
Personally, I would say no. There's no reason for it, especially now that the Raspberry Pi 2 is out. This is basically my question. What will Intel do next to counter that? Before this, it's just 2.5 weeks ago that they announced the Raspberry Pi 2. Now, the Intel Edison is definitely way faster than a Raspberry Pi 1, the original Raspberry Pi. So if you have any application where you need more processing power, like say you try to do something with basic OpenCV, graphics recognition or something like that, for there it would basically be the Edison would definitely be the better choice in that case. But since the Raspberry Pi just came out, this is, I think, which will be a little bit of a game changer, where Intel has basically to play catch up again to come up with something that could beat the Raspberry Pi, so they can actually get into the market. This is everything that Intel has done so far, from my perspective, is they try to catch up. It's kind of interesting what they did, basically, even with coming up with this quick solution from the Intel Edison, the original one with the SD card size, and then didn't even really release it until then in September. They came out with the second generation Edison, which then had the dual core CPU inside, which was then ahead of any other board around there, at least, let's say, below $100. So they were definitely leading there. But now that the Raspberry Pi 2 is out there, I think this is something that is completely changing there again.
Actually, I had something to add on that first question. It seems to me like the Edison is a great thing for this really space constrained still, because even the bigger one is still pretty tiny. And the other thing I think is that the Raspberry Pi doesn't do that Arduino Shield stuff. They have their own, what do they call them? The Pi, what goes in a Pi? The hat?
Well, okay, there are two different things. In terms of the size, the catch is that with the Edison, as small as it is, you can't do actually that much. You need to have some breakout board to connect it to, even if you use.
But if you're building your custom hardware for a project, building a little bitty breakout board shouldn't be bad.
Well, the problem with, let's say, doing your own, so really do-it-yourself board, which is common in the Arduino world, because you have this tiny heroic connector there. This is very difficult even to solder this up. This is surface-mounted stuff, which I don't think that even you need to be extremely good at soldering yourself that you would be able to put that properly working on a do-it-yourself board. As I said, the SparkFun breakout boards with a stackable solution, this is probably from the size-wise the best solution there, and would give you basically some options where you are restrained in size, and then just basically the thickness basically where you would just be limited possibly. But if you basically just come up with a baseboard and have one sensor board on top of it, you're basically about an inch in thickness, so that might work for you. On the other side, the Raspberry Pi, it's not that you cannot use Arduino Shield. There are actually add-on boards for the Raspberry Pi which translate the Raspberry Pi I/O GPIO pins into a Arduino standard Arduino version 1.0 compatible Shield connector. So I haven't used those, so I'm not quite sure what exactly the limitation on them, which port or which pins might not be available on that, but you could do that on a Raspberry Pi. Use Arduino Shield, so that is not necessarily completely excluding that.
So are people doing anything interesting besides Arduino stuff with the Quark in there?
So I mean, I have a little bit
on their Edison board. Sorry, change of topic. Now I'm done with the tagging onto the first person question. So my own question is actually on the Edison. Are people doing anything interesting with the Quark in there yet, besides the Arduino compatible libraries?
Well, as I said, one thing is if you boot the Yocto Linux of the SD card, not the built-in Linux that is on the flash ROM, there you have almost full-fledged Linux distribution, where Node.js is basically the most common, what I have seen, environment where you can program your application on the Edison, and you have a gigabyte of RAM to work with. So that is not, it's not a desktop computer. So a gigabyte, if you see this in embedded terms, is huge. So you don't have to use the Arduino Shields and programming environment to do something with the Edison. You have the option to go with the Yocto Linux. So you basically have three options. I'm not. And on the Edison, it's handling the I/O. There is actually they call it Viper OS. This is basically a real-time OS, basically, which communicates internally with the Yocto Linux to give the Atom part or software that runs on the Atom access to the GPIO pins, which are within the Quark chip. I have not been able to test that. I ordered an Intel Edison. It has been, as I said, it came out. It was announced in September. I tried since December. I tried when I basically signed up here for this talk. Tried to get hold of an Intel Edison. They were sold out everywhere, and I finally got one ordered 12 days ago, and it's delivered probably as we speak at my business address in Brentwood. So I hoped it would have come at least yesterday, that I could bring it in and check something on it. So I'm not quite sure what the restrictions are. I know that on the Intel Galileo, which runs it at 400 megahertz, they are able with this fast mode I/O to get up to 2.3 or 2 megahertz pulse on the I/O pins. So that would still give you roughly the 2 to 3 times, I would say, practically probably the I/O speed that you could get with the 100 megahertz Quark chip to do I/O on the pins on the Edison.
Do you know if the Yocto BSP is available for the Galileo and the Edison board?
The
Yocto BSP to build the embedded Linux.
Yeah. The Intel Galileo or the Intel is basically one of the reference implementations that they have from Yocto.
What are the power consumption stats like for the Galileo and the Edison? I know it's kind of broad, but do you have any real-world idea what the power draw is?
Yeah, sorry, I have a bit background noise. I couldn't hardly hear you.
What is power consumption like on the Intel chips compared to...
This guy, David Hunt, who made this benchmark, said he's including only things that are effectively 1 watt or less.
Okay.
1 watt. So it might depend on what you basically put on add-on boards on it. But from the power one, this is why they use this particular add-on chip, which you cannot get anywhere else, which is used for cell phones. So they basically try to drive down the power consumption as low as possible. It's not even comparable with the regular add-on chip that you would have, for example, in a notebook or anything. It definitely uses way less power than that. So, and he said he includes in his benchmarks. I actually pointed to the. I think on the previous. There, I see. I think if you go to the website there, he has a blog where he basically explains what he does, and he has a lot of other interesting comparisons about that.
So, based on what you presented today, I guess we can assume that you're saying Raspberry Pi 2 is probably.
Well, as I said.
But my concern is that could it be because it's so new that people have not tested?
Well, as I said, when I started basically making the talk here, I would have said, if you want to have something powerful, use the Intel Edison. Yeah. That is, at this point, let's say 3 weeks ago, that was the best bang for the buck that you could get. This all changed basically on February 2nd when even Upton announced, okay, now here we have the Raspberry Pi, and this is where everything, in my point of view, changes basically, where Intel needs to catch up again to. They had a good chance to get a foothold on it with all the little quirky things. It's now the second generation of the Galileo, second generation of the Edison. So they have improved a lot of the let's say, early mistakes that they made. So that has improved. now they have to catch up again to catch up on what the Raspberry Pi brings. And for example, Arduino, they try to bring out a new board that's called the Arduino Tray for more than a year, which is basically a combination out of an Arduino Leno. It's also a hybrid board, and it uses basically the hardware and CPU of an BeagleBone Black, which basically, if you look at the specs for a BeagleBone Black, and from the speed, basically, the BeagleBone Black was faster than what you had on your old Raspberry Pi, but the Edison was faster than the BeagleBone Black. So I can imagine that now Arduino also has changing their plans together with BeagleBone to come up something that can bring those bars down in their favor to catch up on both the Raspberry Pi and on the Edison.
But the second part of my question was that Raspberry Pi 2 is so new that people have not tested it everything, all aspects of it.
Well,
No, I'm saying it could turn out that most of what they're saying are claims. They're not proven as
well, they have sold 500,000 of those in the last year. And I know there were some projects on the internet where that I've been following, where they basically said once they got the Raspberry Pi 2, they got even something directly from Raspberry Pi, and it was a drop-in replacement. Recompiling for the 4-core is the worst that they might have to do, and everything just works just the same. The camera works.
Ralph, we got time for one more question right here.
Yeah, I was just wondering how the interrupts are handled between the Quark and the Atom. Do they have their own kind of management for that? So, for example, if you're driving some I/O through the Quark, does it send an interrupt to the?
I honestly don't know exactly how this works.
Okay.
I know from the Arduino Yun, for example, which is one of the boards that I have used myself, which has a similar arrangement. They basically have an AVR-based chip, pretty much an Arduino Leonardo that does all the I/O, and then you have a MIPS-based chip running Linux, which is basically your outside interface. And there they have something that is called the bridge, basically a serial connection between those two. My understanding is that they have a more direct connection between those chips on the die itself.
Okay.
So this is, for all practical purposes, as far as I know, transparent. So if you program on the Atom chip, you use, at least with the Arduino IDE for sure, there is nothing special that you have to do to talk to the something like the bridge on the Yun. You just write your Arduino sketch for the Edison, and you just have the pins, whatever you can access with all the features, and this is handled completely transparent. You don't have to use the bridge begin and bridge end, things like you have to do on the Yun, where this is literally two concurrent running processes. So here basically they just use the Quark chip on the Edison as the I/O chip, like on the original PC you would use an 8254 serial chip to drive the serial RS-232 serial port on a PC. So that is, for all practical purposes, it should be transparent.
Thank you.
Yeah, these will. I have to email them to one of the people here organizing with the speakers, and they will be available on the SCaLE website. The previous one. Oh. The.
Thanks, Ralph, for a very comprehensive presentation. Appreciate it.